Hello everyone, welcome back to my YouTube channel. I am Chandana from CSE Sri Venkateshwara College of Engineering. This video is based on analysis and design algorithm on the topic of Kruskal algorithm for minimum spanning tree. First, what is Kruskal algorithm? Kruskal algorithm is a well-known algorithm to find the minimum spanning tree of a graph like weighted graph, connected graph and undirected graph. Let us go through the introduction. I already told that Kruskal algorithm is a greedy algorithm used for finding the minimum spanning tree of a connected weighted graph. This algorithm is particularly useful in network design and optimization problem. It efficiently connects all vertices with the minimum possible total edge weight. First, what is minimum spanning tree? Minimum spanning tree is a subgraph such that all the vertices of exist in the subgraph. Subgraph should be connected and it will not form the cycles. Why do we call minimum spanning tree? Because the edges we include, sum of weight of those edges should be minimum. Let's take a look at the Kruskal algorithm using an example. So this is going to be the graph that I want to construct. So what we are going to do in Kruskal algorithm, keep including minimum edges as long as no cycle is formed. Note that finally subgraph contains all the vertices. Let's first draw all the vertices. Now let's start the including edges. What are the minimum edges in this set? Now the minimum edge one here and here. First let me include this. Next minimum edges is this, so I include that. Now in this set, what is the minimum edge? And we have a 2 here and here. First I include this and next this. I have a next minimum edge is 3. Now can I include this edge 3? No, I cannot include the 3. Because when I include the 3, it will be formed cycle. It is formed cycle, I cannot include 3. Now I go to 4. Can I include that 4? No, it will also form a cycle. Now I go to this 4. Can I include that? Yes, because it is not form any cycles. Now I go to 5. Can I include that 5? No, it will form a cycle. The next largest we have 6. So now we have 7 and 8. We include 7, it will form also cycle and 8 will also form a cycle. I cannot include 7 and 8. We have connected all the vertices in the minimum spanning tree. Now we can stop. What is the weight of minimum spanning tree? 6 plus 4, 10. 10 plus 2, 12. 13, 14, 15, 16. We have 16. Prerequisites. Understanding graph theory is essential for graphing Kruskal algorithm. Familiarity with data structure like distance sets is crucial for implementing the algorithm efficiently. Basic knowledge of ADA programming language will help in writing the algorithm. Algorithm overview. Algorithm begins by sorting all the edges of the graph in non-decreasing order of the weights. In this initialize a forest where each vertex is a separate tree. Edges are added to a MST as long as they do not form a cycle. Step 1. Sorting edges. This can be achieved using efficient sorting algorithms available in ADA. This first step is sort the edges of graph based on their weights. Sorting prepares the edges for symmetric evaluation in subsequent steps. In step 2, we initialize the trees. Each vertex in the graph is initially treated as separate tree. A distant set data structure is used to manage these trees. This structure allows for efficient union and find operations to prevent cycle. In step 3, we select the edge. For each edge, it checks if adding it would create a cycle using the distant set. The algorithm iterates through the sorted edges one by one. If does not create a cycle, the edge is added to the MST. Cycle detection. In cycle detection, it is crucial for maintaining the properties of a spanning tree. The union find data structure is employed to check for cycles efficiently. Two operations, union and find, are used to manage the connection between vertices. In edge cases, Kruskal algorithm handles cases like disconnected graph by returning multiple spanning trees. If the graph has no edges, the minimum spanning tree is empty. The algorithm is robust against varying graph structure and weights. Complexity analysis. The time complexity of Kruskal algorithm is 0 of OE log E, where E is the number of edges. Sorting the edges dominates the time complexity while the union find operations are nearly constant time. The space complexity is 0 of V plus E for sorting the graph and the distant set. Implementation in ADA. Implementation Kruskal algorithm in ADA involves creating a data structures for edges and distance set. ADA's strong type system helps ensure type safety during implementation. The syntax and structure of ADA can make the implementation straightforward. ADA code example. In this example, it is generated code with return inside C data n, private int value, public int value get, return int value set, int value equal to value, public action result abort. In this example, below is a simple code snippet showing the key components of Kruskal algorithm in ADA. The code illustrates how to define edges and manage the distance set, proper comments in the code, and enhance readability and maintainability. Example graph. In this example graph, consider a weighted graph with vertices and edges of varying weights. Visualizing the graph helps in understanding how Kruskal algorithm processes edges. An example graph can be illustrated the step-by-step selection of edges. Resulting minimum spanning tree. After all, applicable edges are processed, the resulting minimum spanning tree that can be visualized. This final tree connects all vertices with the least cost. The total weight of the selected edges is the minimum possible. Applications of Kruskal algorithm. Kruskal algorithm is widely used in network design such as connecting computers in a network. It is also applicable in clustering data points in machine learning. Other applications include designing roads, network and telecommunications. Conclusion of this topic. Kruskal algorithm is a powerful method for constructing minimum spanning trees. Its efficiency and effectiveness make it suitable for various applications in computer science. Understanding its implementation in ADA can enhance problem solving skills in algorithm design. Thank you for watching my video.